Hello everybody, my name is Ben Haldin and I'm the Managing Director of Fulcro, and it's my pleasure to talk to you today as part of this Beyond BIM 2020 symposium set up by Desktop Engineering. So thank you very much for Desktop Engineering for organising it. And using the strapline as a kick-off point, the vision of the future, I'm using people, process and technology to present an aspect of how we can improve our delivery, therefore presenting a brighter outlook to the future of our fantastic industry that we're all involved with. And I'm going to start by just positioning Fulcro, and doing that using these fantastic car brands that you'll all be familiar with. And some of you, or most of you, will also be familiar with the AMG badge associated with Mercedes, the RUF badge associated with Porsche, and drumroll of drum rolls, ProDrive associated with Aston Martin. Now each of these brands, coupled with the main brand, produces a product that is faster, more agile in use, and has increased performance. These are all projects, or a sample of some of the projects that Fulcro has had the privilege to be involved with. And like the brands I've just referred to, Fulcro contributed to the enhanced performance of this process based from design through to construction, and where we were either assisting in the detailed design to enable betterment of operation, or assisting in the detailed design and construction interfaces to enable betterment through construction and assembly. All of these projects benefited from our involvement. And the next slide, or should I say video, presents a outlook and a understanding of the merger of processes and technology. And it also gives you a slightly younger looking Ben Haldin.
There's a huge track record based around computer technology, computer scientists, programmers, which manage that data. And together we are able to produce a new process that will bring together a more collaborative environment of concurrent, simultaneous engineering based along lean principles that would create the next generation of project delivery and result in faster, better and more improved results for us.
That should have ended more improved results for our customers, clients. So in summary, Fulcro is a unique, agile, niche, specialist, fantastic group of architects, engineers, designers, technologists, computer programmers that enable faster delivery with improved quality, always looking at increasing value for all stakeholders. One of the challenges that I consistently speak about is the plan of works, the traditional historic nature of breaking up the design process into stages, and where you could present risk avoidance, risk reduction, risk transfer and risk impact as benefits. I worry and have evidence of and experience of individual design teams, work packages, construction teams actually using these work stages to mitigate their own risks, reduce their own risk transfer impact, and the collective impact of that is a reduction in value for the total outcome of the design and production construction process. Therefore, you get a little bit of I'm looking after myself, and not we should all look after ourselves. That then does lead to challenges with respect to disconnects, as evidenced by this fantastic graphic of scissors that I managed to crib off the internet. And it basically communicates there are disconnects between the consultant and the contractor and fabricator, and sometimes the client, not represented on this slide, but ultimately the project will suffer. And this is evidenced by the building Chartered Institute of Building. 60% of projects are late and over budget, And I believe that that demonstrates a real need, as all these reports did, the Egan report, Latham, we've had all of the conversations about the betterment of building information modeling and how we should improve, but it's really about everybody understanding the following: that there is another way, and it's right under our noses. And that other way is we have to find a way to bring the manufacture and assembly processes and technologies, which ultimately drives the procurement and logistics of a project, into the design phase. And then we have to educate our clients that they need to adjust their spend profile to start producing designs that are construction ready as part of the normal process and business as usual moving forward in our industry. And by doing that, we can eradicate the cost of change for coordination, which is depicted by the yellow-orange curve going off up to the right. And the way we can do that is educating our people and embedding a new process, and then coupling that with technology. If you don't do that, then you will just applying technology to a linear traditional system, as I'm about to illustrate. The diagram on the left is a traditional individuals with tasks, doing what they've done before, doing what they were told to do from the generation before, and it's very linear. We want to move to a more collaborative, integrated process. We want to make sure that people understand the roles, their accountability, and the processes and the contribution they need to make. And that becomes even more evident when you start using collaborative workspaces such as 3D Experience to get ahead in this industry. And if you are able to follow this process and move, you get a better, more productive thinking, you get a shorter, more productive meetings and project groups, which results in improved communication and collaboration and understanding. And we really need to move to a concurrent, simultaneous approach, as illustrated by the right-hand diagram, and move away from a traditional systems engineering, sequential, centralized design from a project view to more of a concurrent team leadership and people recognizing the roles and contribution they make to the whole and not just looking after themselves. And the other key factor of this new way of working in this group is we have to move away from the master and servant, or the upstairs downstairs chip on the shoulder that I have with respect to CAD users and technicians. We have to make sure that people understand that a designer is a designer who can use a CAD system but also contribute to the design. And this is a classic example that I'm using here, and I'll evidence it by, on the top left, that is a normal design intent engineering line diagram for a drainage system that an engineer would produce. That would then go to a CAD technician to draw up, and then that will then go onto a set of drawings, then it will go to site, then somebody will start getting the components together and realize that there are inverts because of components, and drainage has to go in at a fall. You have swept bends, you have to rotate bends, and the other diagram, the other images just illustrate how that manifests itself through into an installation. These are all things and skills that need to be brought forward into the design phase that I've just evidenced in that diagram with the bell curve and the cost of change. And if you can do that and create that environment, then you have a wonderful, let's call it next generation arrangement of working. And we have people in our business, generally the younger, but everybody's aligned to it, but there's a more acceptance of an expectation of doing things differently. And if you get that people and process correct, then you can start really pushing the technology and asking the right questions of it. And I've just got a short video to illustrate a vision of what we expect and would like from our technology. There are many components such as planning, FM, client, design teams that contribute to a digital prototype, a hub, a database. We want to start using the Internet of Things, AI, but we must understand that everything has to start with a component or an object. So here you have an illustration of the shapes, the group geometry that gets assembled for a door. You then have an I-beam or a piece of pipework, but all this geometry has to be checked and validated and be present correctly into the system, which is the digital prototype, the collaborative working space. And if you can do that, when these objects and components go in, then because they've got a taxonomy and a data structure, we can ask our engineers, designers of the technology systems that we use to start creating intuitive, automated processes within the environment we work to help improve and speed up the design of a building. And an example of how that works today is this, which is a set of work packages associated with the fit out of a set of apartments. There were 28 or 26 apartments, I can't quite remember, on this particular building. And we said that we could create a digital prototype using the design and work with the designers to give you a as installed, as assembled, as an in operation state of the building based on this apartment, to look at the fit out and contractual construction durations while validating the design and the detail. And this is a screenshot of a digital prototype. All of these images come from the same data, and we have a video simulation, we have it linked to a 4D construction program, and then each of these components also then linked to the particular work packages, so we understand that the kitchen fitter needs to come in and do a second fix, second fix before they assemble. We also adjusted walls and things to reduce the amount of a variant from off-the-shelf components. We've got all of the background, the skeleton to do with the internal partitions, the sprinklers. We've got all the secondary fix items in there. And this resulted in us testing and validating and producing a deliverable activity program, integrated design and construction program, assembly program, which reduced 3 weeks off the apartment build. That 3 weeks can be replicated across the 26, 28 apartments. I won't do the maths, but that is a significant saving in cost and based on time equating to value. And I'm now going to evidence a few more examples of how this process benefits. And this is a 10-year-old project, I believe. It's a teenage cancer treatment center. It's got a double height basement, and in this particular project detailed all of the internal services. We did all of the wall elevations, all of the detailing of the builder's work, the bedhead assemblies, the in-wall equipment, and we produced all of the set out documentation. And the digital prototype was deemed to be so accurate, and the confidence within it, we take professional indemnity for the construction documentation we issue, that actually all of the setting out of the ceilings and above ceiling services were done through a Trimble total station, so that trades were coming onto site with their components, knowing exactly where the location to assemble and build to. This is an example of a federated model based on the Lime Street, the Scalpel development in central London. And in this particular scope of work, we were looking at validating and verifying the design detail. You can see the detailing of the steelwork structure, which was brought in by the manufacturer. We then added the detailing to do with the glazing, and we were also looking at the BMU and services for vent, which were omitted or missing from the design in the early stages that were picked up And here is an image of that vent, and you can see the BMU arm off there in the left-hand side of the picture. Another project, which is one of my favorites, is a 32-story, 363-bed mixed-use rental PRS building. This is what I believe to be the world's largest volumetric modular building. What I mean by that is that it had no structural core at all. The whole building was assembled by stacking these modules on top of each other, and then it was tensioned together with a mass stamper on the roof to do with the structural integrity, because the building ended up being a lot lighter than a normal building. The building is in operation. It has been in operation for many years now. It's called 461 Dean Street, and the client is very happy with it. We visited it twice last year. It's always 95% occupied, and it's operating and functioning as a successful building. And each of the modules were assembled with sub-assemblies of bathrooms, and it was all assembled in a factory with the facade systems on it. It had all of the white goods in it. It was about 97–98% completed before it went to site. The remaining percentages were mateline pieces and some timber flooring in some of the apartments to do with the kitchen areas, because the specification of it wouldn't allow it to be installed in the factory during some of the phases of installation because of the temperature variance in New York. We couldn't assure that the temperature was right for the timber flooring to go down, so that was installed in some of the apartments on site. And here's some pictures of finished apartments. Another example is Dudley College, and this was an example of a group of people, including a client, recognizing that if we were to work collaboratively and we had a shared project bank account and the project was collectively insured by an integrated project insurance, we could deliver betterment for the client and share in the rewards. The project was put together by these key groups of individuals, and we won a Construction Excellence Award, National Award. We won a regional award, and the project was delivered with a 6.5% saving against the planned investment target that we were all aiming for. The building that is associated with that particular award is the building on the top right with the red accents on the roof and on the side. The building on the left is the first building we did for this particular client, and we have just been awarded, well, we're 12 months into working on a third building. So success really breeds success, and that is something that we could really do within this building industry, so that we can pull ourselves out of snapping back to a traditional linear process of delivery that I talked about at the beginning of this presentation. And how Fulcro does this, how we evidence what we do, how we assure certainty, how we deliver value and surety, and something that the future of this industry should deal with, is that if we're working in a digital environment, we can then view it. And by viewing it, we can validate and verify it. So here we have a 2.5 meter cubed environment, which is a 1-to-1 scale model. So what I'm saying is you can load up your digital prototypes within the Fullmax, and as depicted by the image on the top right and bottom right, you can load up your live CAD data. You can pull in live scan data or 360 videos from the sites, and you can stand in there with the key members of your team to look at their faces so you can assure that there is trust and integrity in what is said. It's not hidden behind a set of goggles or glasses, to get confidence that you are resolving issues, delivering solutions which meet the brief and that can exceed client expectations. And here is a video of a group of our technicians who are looking at scan data, and they are loading up their own model geometry, and they are reviewing and validating and placing comments on the model for a preparation for a design review with potential trade contractors to take on board the role of fabrication and installation. So thank you very much for listening to me. There's an awful lot more that I could talk about, but the upshot being is that I really believe that we can deliver betterment in our industry by adopting the technologies that are available to us, but ensuring those technologies are underpinned by people with the right skill set and the right collaborative attitude to get maximum value from today's technology for tomorrow's buildings. I'll be happy to take any of your questions. Thank you very much.